These gels show analysis of the purification that we attempted on beta-lactamase. So here's markers in the middle. That's 25 kilodaltons, 3750. So the band we're looking for is right here. This sample here looks actually pretty good. It has the beta-lactamase at a decently high concentration and not a lot of other bands. So this purification looks excellent. This one here has the beta-lactamase enhanced. It has some other bands, but it's better than the crude PPE that we can see here in lane 4. The most interesting data to me is over here in lanes 1 and 2. So lane 4, that's crude PPE. Lane 3 is a fraction from the ion exchange that contains beta-lactamase. So you can see there's the lactamase enhanced. Relative to all the other bands, it's been enhanced. This fraction here came out after beta-lactamase. So this is the high salt fraction. You can see it has lots of proteins in it, particularly these up here. It does not have a nice band for beta-lactamase. So that's why it had no enzyme activity, but it has plenty of the other proteins that are found in PPE. This lane 1 has an early fraction with the low salt, 75 millimolar, I think. This one's nice because you can see there are very distinct proteins that came out at that point. There's a suggestion that this might be the lactamase, but the assay, the enzyme assay, says no, this is not beta-lactamase. It's a protein that has a similar molecular weight, but it is not the lactamase itself. So perhaps in this crude PPE here, there's actually two bands very close in molecular weight, and that's why this may be rather thick, because it's two proteins almost on top of each other. But this is what you look for when you fractionate. These proteins are junk, but they're distinct proteins. We can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 major proteins came out here. And this is the high salt, and that's harder to count individual proteins because there's too much background. But we certainly have some distinct bands here. And this one is enriched, but certainly not purified yet. The specific activity of this fraction is higher than we started with in the crude PPE, but it's not yet pure. So to get a pure protein, you do more steps. And one of the things that you could try would be to fractionate on the basis of size, and perhaps separate this one from this one. And that is something you may be able to do next week. Another approach is to do ion exchange with a different kind of resin. So we used a DEAE resin. That's a cationic resin, so it binds proteins that are negatively charged. We also could use a negatively charged resin, and that would bind proteins that are positively charged, so that might help isolate the beta-lactamase protein. Modern techniques often use something called affinity chromatography, where you a special molecule that binds to the protein that you want, and that allows you to really clean it up because of its affinity for this one special molecule. Here I've zoomed in. This is an early fraction here, low salt. This is a high salt fraction after the beta-lactamase, and here's the lactamase containing fraction in the middle of the salt gradient.